Hello everyone. Next I will introduce our lightning impulse test device. Let's introduce to you. And here's one of our control units to monitor one of our waveforms and control voltage output. As you can see here, we have an experimental change. This is our charging part, the charging part, and the PLC control part of this equipment. The control part, from our high-pressure terminal to ours. Capacitor. The capacitor here is for groups of main capacitors. And these three resistors are our charging devices. This is our discharge. For discharging, the resistor here is used to adjust the waveform. This is a full wave set. Then if it is a cut wave, we do the one behind. What we are demonstrating to you now. So it's a full wave one. Introduction video. Then the high voltage output from above goes to our voltage divider. Our voltage divider now has two functions. One is to monitor our high voltage, and the other is, it was exported from above to one of our subjects. When we conduct impulse voltage tests on switches and other samples, the high voltage output terminal of the equipment is connected to the test specimen. Okay, we're just going to ascend for a demonstration. You can see our operation cabinet. There is a ground and a control output line here. And this is our power supply. And a voltage measurement, which is connected to the impulse voltage measurement of the voltage divider. And here is for current waveform measurement. Because we don't use this now, so we don't need to connect it. Then here is a 220 power supply. Then to our PLC cabinet. This is a line from the control box. Control box, control line, and the switch cabinet line. It's ours. The charging and discharging part. It's connected to our on a device for charging and discharging. This is the power cord that powers us, which powers our PLC cabinet. This is a wire to our control cabinet. Okay, let me demonstrate it to you. For example, we set the charging voltage to 20 kilovolts. Okay, then this automatic bulb pitch. Click. Okay, let's set the voltage to 20 kilovolts. It's just for demonstration. Click on automatic bulb distance. The discharge gap behind will be smaller. Okay, it will shrink to the specified value. Then for our oscilloscope, we will adjust the parameters. Our default voltage is 20 kilovolts. 80. Okay, then click Set Oscilloscope. Okay, the settings are done. Then we can check it. We adjust the parameters. It shows a positive polarity and a negative polarity. We are using the negative polarity now. The adjustment of positive and negative polarity, I'll show you later. There is an operating lever behind. You can see it. Okay, I'm switching to positive polarity now. The diode it will adjust our polarity state. Our positive and negative polarity is through this diode to switch. Start. For example, we have switched the polarity to positive polarity. The oscilloscope here shows. To modify it to positive polarity, click positive polarity, then set the oscilloscope. Okay, let's click Start Test. Now it's in a state of waiting for triggering. Okay, now we start the high voltage. Okay, now the voltage has risen. We have two triggering methods here. One is manual and the other is automatic. We're using the automatic mode now. It reached our set voltage. It will start the test. Click to start charging. OK. After charging, it has already conducted a short test. For example, let's say we have now completed the high voltage disconnection, and here we can see a waveform. Our first half wake is a positive polarity waveform. Here we can see a T. One value of T2 is 1.253 microsec. Theta is 53.712 microseconds. The maximum voltage is 47.63. This is our positive half cycle. It's the voltage of our positive polarity. If it's negative polarity, there will be a waveform in the second half wake. OK, after our instrument is tested. For example, if we have to bring a test subject, our test product should also undergo a discharge. When we discharge, this is the main discharge connector, and the front is a straight joint. We screw the square to the main discharge, and then add the ground wire to the head of the assembly. There is a section of electronics inside. When discharging, we should discharge first. After the main discharge, we will do a direct discharge, including the discharge head here. Also need to be discharged in turn. Then all these heads need to be discharged. I only discharge one head here as a demonstration, but in our normal experiments, all need to be discharged. OK, that's all for the instrument introduction.